Good morning. I'm going to give a little talk on middle school science. More people watch elementary stuff than the advanced stuff. The last talk I gave was on tensor calculus. So this is to do with density. Keep it as brief as possible. Density. It's traditionally taught anywhere from 5th, 6th, 7th, 8th grade. But believe it or not, it's actually covered in an elementary introductory course at college level too, because they go over all that stuff again. I remember I taught this stuff down in Florida at a university, technical university. Density. I taught it to a higher level though. I'm only going to do the basics for middle school kids. So, what about density? Well, I'm going to go back to Archimedes. Now, Archimedes lived 287 to 212. Does that look funny? He seems to be getting younger as the years go by. Well, it's BC, that's the reason. Okay? Before Christ, if you like. BC. So Archimedes lived in Syracuse in Sicily. Now, the Roman Empire wasn't always the huge one. At one time, around this time, actually this year here, 212, there was another empire, the Carthaginian Empire. And it covered south of Spain and most of North Africa, right? Now, at the time, I think, when the Roman war broke out, there was a Roman general, I think his name was Scipio, I can't remember for sure, but I certainly know that the Carthaginian general was Hannibal. And Hannibal is famous for bringing a herd of African elephants, well, there could have been Indian ones, I don't know for sure, but a herd of elephants nonetheless, all the way up through Spain, all the way up through France, up to Switzerland, and across the Alps to attack Rome. How about that? Quite an achievement. And you know, some of the battles fought at that time in that war, it's called the Carthaginian War. Oh, actually some people refer to it as the War of Hannibal. So, the war was fought between the Romans and the Carthaginians. Yeah? And amazingly, we still have evidence of it today. Where? Cartagena in Spain bears that name still to the present day. Okay? So, Archimedes was a great mathematician and a great scientist. He did phenomenal things. He worked out the area of the sphere, the volume of a sphere, for example. How to do that? That's not easy when you don't have calculus. 4/3 pi r cubed. Wow. Using limiting processes. So he had the rudiments of calculus actually a little bit beginning to be under control. In fact, if the library of Alexandria had not been burnt by the Romans and the books used to stoke the fires of Rome for a long time, then more of his works would have survived for us. We've only got a few of his works left. So he did many things. He was a dangerous person to the Romans, by the way. He could make weapons. He made one weapon for dragging ships up in the harbour and they would sink backwards. He supposedly set fire to the sails of Roman ships in the harbour. I'm not sure. It could be Alexandria or it could be Syracuse, I'm not sure. Using parabolic mirrors, because Archimedes knew that a parabola reflected and focused light to a point, parabolic mirror. I need to get a better marker. A section of a sphere focuses light as the light comes in. All the rays don't get focused to the same point. I'm not drawing this very well. Can that? I'll do a lesson on this some other day. One way or another, Archimedes knew that the parabola, or a paraboloid shaped mirror, focused the rays of light to a more focused point than a spherical shape. and many other things. But he also studied density, and that's what we're talking about today. Okay, what is density? The first thing we'll do is we'll go back to the gram. That's where he lived. By the way, for future reference, I'm giving out an email address, doreilly@physicist.net. So people who find mistakes in my work, there are about 28 or 30 different talks, and I often make simple mistakes. I don't make big ones. I might make a simple mistake like writing down a 3 and a 2 instead of a 2 when I'm saying 3 and I mean to write 2. Things like that. Yeah, so what about density? We'll define it first. That's always a good way to begin. Sometimes people, when they're teaching, talk around the topic, don't hit the nail on the head. Here we hit the nail on the head before we go. Is defined as, if you like, it is. It is this. It is the mass of unit volume of a substance. Now, what could be the mass of a unit of volume? Well, what could be our unit of volume, first of all? Unit of volume could be cubic inch. And we could talk about pounds per cubic inch. Pounds are not strictly mass. We could take a cubic foot. Cubic foot, let's say, of iron, and find out its mass. Okay, 1 cubic foot. We don't use pounds and feet currently. We're going to stick with we'll stick with the simplest units we can play around with. They are SI units, or the metric units. Now we have a choice of many units of volume. I'm actually going to use grams because kids have a better feeling for densities in grams than if I was to use kilograms, or if I was to use cubic meters. Okay, so we're talking about mass in grams and volume in cubic centimeters. Some people write cm, cubic centimeters. Sorry. That's not entirely correct, right? Let's see why. Cubic centimeters, okay? A centimeter is 1/100th of a meter. You can also write it as 10 to the power of -2 meters, right? Now, if we want a cubic centimeter, that's going to be a centimeter by a centimeter by a centimeter. So, a cubic centimeter is as follows. It's 1/100th of a meter to be cubed. So you have to be very careful when you play around with the units. Now for the middle school, we can probably ignore this little bit of stuff, but for the later middle school, or getting up into high school, we need this. Now, 100 cubed is 1 followed by 6 zeros, right? So 1 over 100 cubed, well that's the same as 10 to the power of 6. 1, 2, 3, 4, 5, 6. It's the same as 10 to the power of 1 over 10 to the power of 6 meters cubed. Now when we have an exponent down, stairs, if we bring it upstairs, we just change the sign. Or we can just use the exponent rule for multiplication. 3 times -2 is -6. This is it. See, that's the kind of mistake I make. Right? So, cubic centimeters will be our unit of volume. And the unit of mass is grams. Okay? So that's our starting point. Grams and cubic centimeters. Now I've erased the board. Now I also forgot to tell you, Archimedes was killed by a Roman soldier during the Punic Wars. Okay, Roman soldier was sent to seek out Archimedes by his centurion. Well, obviously, why? Centurion was worth more to Rome alive than dead because he made these great weapons. So the Roman soldier eventually located Archimedes, and he was calculating on the ground, in the floor, in the sand, I don't know where. It's not entirely known about the details. So Archimedes said, don't interrupt me because I'm calculating right now. And of course, that frustrated the Roman soldier, who took out his sword and killed him. Some legends have it that the Roman soldier in turn was killed, but who knows? Anyway, that's how Archimedes was killed. He was getting old by that time, but he was still productive. Now, the density of pure water and the definition of the gram. Basically, they're the same thing. How do you invent a gram? Well, they begin with a unit of length. The unit of length is the meter. And the meter was invented, and it was suggested by Sir Christopher Wren, to make a unit of length that we could duplicate anywhere on the surface of the earth. And the only thing that affects the time for a swing of a pendulum is the length of the string holding the bob. So if we take a length of string that generates a period of a half period, that's once. Here's a whole period for a pendulum. 1 and back, over and back. And this is a half period. So this to be 1 second needs a string of length, which we now call 1 meter. So we've got the meter. That's what the meter is. Now 100 centimeters is 1 meter. And a centimetre, we already said, is 10 to the power of minus 2 meters. Minus 2 is the same as 100, so 100 over 100 is 1. So therefore then, we're all set. 100 centimetres equals 1 metre. And you have a look at your ruler. A centimetre is about the width of your finger. Okay? In the case of the middle school, it's the width of your nail of your thumb, approximately. So how do we make a gram? Take a cubic centimetre, and I'm getting careless with my own notation. I won't. We'll take a cubic centimetre, and it's empty, and we'll fill it. On the inside has a volume, or let's say the walls are so thin that they don't matter. So we fill that cubic centimetre with pure water. And we put a little metal weight over here and we say let them balance. So that they balance now, and we can duplicate this guy as often as we want. We have a cubic centimetre. Sorry, cubic centimetre of water, and the mass of 1 cubic centimetre of water is 1 gram. Then we'll choose certain conditions. We'll make sure, I'm just estimating, just room temperature. We're not going to worry about atmospheric pressure, stuff like that. The mass of 1 cubic centimetre of water is defined to be 1 gram. Okay. Question. What is the density of water? Well, I've just said it. We're going to choose the unit of volume to be our cubic centimetre and the unit of mass to be 1 gram. The mass of 1 cubic centimetre of water is 1 gram. We'll use the symbol rho, Greek letter R, rho, to denote density. If you want to use a D, you can. If you're happier with D in middle school and 5th grade, use a D. D for density. So the density of water is this. This is how we say it. The density of water is 1 gram per cubic centimetre. And that means every cubic centimetre of water has a mass of 1 gram. For this talk, our units of density are going to be grams per cubic centimetre. Okay? Let's move ahead. What is the mass of 10 cubic centimetres of water? Mass of 1 cubic centimetre is 1 gram. The mass of 2 cubic centimetres, what's that? 2 grams. 3 cubic centimetres, 3 grams. The mass of 10 cubic centimetres of water, 10 grams. What's the mass of 1,000 cubic centimetres of water? The answer is 1,000 grams, right? What do we call 1,000 grams? So the mass of 1,000 cubic centimetre of water is a kilogram. Let's do an aside. Now I don't like using litres. Chemists mostly use litres, but if you're using litres, 1 millilitre will be the same as a cubic centimetre by definition, okay? Alright, so what is a milliliter? Milliliter is 1,000th of a litre. 1,000 is 10 to the power of minus 3 as opposed to 10 to the power of minus 2. 1,000 can be written as 1 over 1,000 or 10 to the power of minus 3 of something, and of as multiplication. So here we have 1,000 cubic centimetres and 1,000 millilitres. We already said that the mass of 1,000 cubic centimetres of water is 1 kilogram. Wait a minute, that's the same amount of water, same volume. And here's something interesting. What's 1,000 millilitres? It's 1 litre. It's the same as 1,000 times 1,000th of a litre. 1,000 millilitres is a litre. Okay? So far, so good. Now this is true only for water as a substance. Well, it's probably true for some other substances, but it's defined true for water. Let's look at another substance and see how different it can be. Well, you guys know that if you hold a piece of lead in your hand, it's going to feel a lot heavier than the same volume of water. Lead feels heavier, okay? So, without finding the density of something, we'll show you, because people get confused. They think that the volume of (3 cubic centimetres of anything is 3 grams. It's not true for anything. Just water, because we define the density of water to be 1 gram per cubic centimetre. So let's look at lead.